So we're going to start with what we call the chain rule. And what's happening is we have a composite function, right? Like when you think back to last year in pre-cal, we had things like f of g of x and g of f of x. Those are composite functions, meaning I plug one thing into another. So when you look at those, when it says find g of f, that means I write down g and I put f inside. Well, the chain rule is helping us figure out how to find the derivative of something like that, okay? So I want to just do some on scrap paper. I think this will work better. We'll do our notes, but I want to start off this way. We're going to do these, which are the ones we did yesterday, and then we're going to compare it to how that would look today, okay? So yesterday, if you had to take the derivative of y equals 6x to the fourth, you would say the derivative is what? 24x cubed. Well, today our problem looks a little bigger. Instead of just having x right here, we have a whole bunch of stuff. Do you see how it looks like we had 6x to the fourth, but we put something big inside? So the rule is you take the derivative of the outside and you multiply it by the derivative of the inside. So the outside of this function is 6x to the fourth, right? So what we're going to say is we're going to use that power rule and say that that's 24x cubed, right? But instead of just an x right there like we had here, we have all this junk, all that stuff. Well, we can't change it because the calculus rules tell us you may only take one derivative at a time. So if we're changing the power, we're taking the derivative of the outside. But y'all are like, wait, there's this whole inside right there. So once we take the derivative of the outside, now we have to take the derivative of the inside, which is what? 3x squared minus 8x. That makes sense? And that's what today is about. You do what you did yesterday, but instead of just having an x sitting there, you have this big thing. So when you're done, you got to take the derivative of that big thing. Okay, so let's look at this. What's the derivative of ln x? 1 over x. So these are exactly, almost exactly the same. So the derivative is going to be 1 over x. Right? But now we have to multiply by the derivative of the bottom. And what's the derivative? 6x plus 7. And of course, this is 1 over, so it's just 1 times that, so you would finish that up. Does that make sense? So really, if you think about it, when you have a natural log, this guy goes to the bottom and then his derivative is sitting on top, isn't it? Not bad, right? You could do that. Each piece is not bad. It's by the time we get done and you got to remember all of it. Yes, ma'am. This one? So just like here, we did the exponent and said 24x cubed. We do the same thing here and say 24x cubed. But instead of just having an x right there, we have this big guy. So he's here. But then out to the side next to it, we have to take the derivative of that and multiply. Remember what it's saying, the derivative of the outside times the derivative of the inside. So the outside right here is 6x to the fourth. The inside is that great big scary x. And we'll practice more. All right, what's the derivative of sine x? What's the derivative of sine? Cosine. So now we have sine of 7x. So now I'm going to say the derivative of the outside, and the outside is sine. So the derivative of sine will be cosine. Now I don't mess with that yet because I just changed something and I can only change one thing at a time. So I did the derivative of sine, which is the outside. Now I have to do the derivative of the inside. What's the derivative of 7x? Just 7. So times 7. Now you don't usually see it written there. When we have a 7, we'll come over here and do 7 cosine 7x. Matter of fact. Now what about this fella? You already told me the derivative of sine is cosine. Now what about him? Remember, trig functions are written a little funny. What this really is asking you for is this guy. That's really what that means. So this is a power rule problem. Bring that 4 to the front. So it's going to be 4 sine x, right, cubed, right? We use the power rule. Now we have to take the derivative of what was inside. What's the derivative of sine? Cosine. Now we don't leave the 3 out there because that's not really proper. That's not how we write it. We think this because it helps us use the power rule. You don't have to go to this, but it will help you see what you're doing. Once you're an expert, you'll just go from 4 and put it in the front. You won't have to worry about it. This is just a way to help you see it right now. So does that give you a good comparison of yesterday to today? Because what we're going to do now is practice a gazillion of them, right? All right, let's do it. So let's look at all the different ways I could write these scary problems to frighten you, and we'll see if we can do them. How are we going to rewrite number 1 here? We don't like square roots. Can we rewrite that with a power? We can, right? I didn't take the derivative yet. It's x squared minus 4 to the 1/2, true? Now are you able to use a power rule? We can, can't we? So that 1/2 will come to the front. Bring it over and we have 1/2 x squared minus 4. Now what's 1/2 minus 1? Negative 1/2. And now we got to take the derivative of that inside. So the derivative of x squared is 2x, right? Now we'll clean this up a little bit. First of all, you've got a 1/2 and a 2. What's 1/2 times 2? Yeah, so those will cancel each other out, right? It's 1/2 of 2. Now the x does not have a negative sign, so that x is in the front, no negative exponent, but this has a negative exponent, so it really belongs in the denominator. And 1/2 means square root. And there we go, all done. Not too bad. It's basically what we did before, but you're taking 2 derivatives every time. Yes, ma'am. So now this one is going to be straightforward power rule, right? So we do the outside first. So bring 4 to the front, and I've got 4. Let me write derivative down. 4, and I don't mess with this inside because that's the inside. Now this 4 goes down to a 3, right? Power rule's okay. But this was more than just a simple x, so we have to take its derivative, and that's going to be 8 minus 4x. And we would just leave that. We don't need to multiply through because our end game is that we're going to end up plugging numbers in for x, and it's easier to plug them into this than it is to simplify. We run the risk of error, right, if we cube that and do all that. Okay. What about this guy? How are we going to write that? Do we like stuff in the bottom? No. Let's take it out of the bottom. How can we get something out of the bottom? Negative exponent. Right? Once we do that, are you good to do it? Now what are we going to do? power rule. Well, that's not the derivative yet. Now I'm ready to take the derivative. That was just rewriting it. Okay, so we're going to -2 times -3 is 6. Now, -2 minus 1. No, -3, right? What am I thinking? And now the derivative of 3x minus 4. 3. Now this one, if I have a simple 6 and 3, I can see that that's 18. Now it's 3x minus 4 to the -3. So I'm going to put that in the bottom. If we leave negative exponents, we can end up making mistakes later, because if we plug a number in and get a 0, we'll be like 0 cubed is 0. But when we put it in the bottom, we realize that's a bottom and we can't have a 0 in the bottom, right? So you're safer to put it back. All right. What's this one? First, we take the derivative of sine. So 3 cosine 8x, right? But 8 was more than just a simple x, so we need to take the derivative of that. What's the derivative of 8x? 8. So now we have an 8 and a 3. So what would we say about 8 times 3? 24 cosine 8x. What about this one? Is that really kind of just like 3x minus 1/2? Does the pi over 2 do anything? It's just a number, right? What's the derivative of a number? 0. So this really isn't trouble. It just looks scary. So what's the outside function? Yeah. So what's the derivative of 5 cosine? Cosine, the derivative is negative. -5 sine. So we've taken one derivative, so we can't mess with this. Now we're ready to take the derivative of that. And what's the derivative of 3x minus pi over 2? Just 3. Because this is 3, the derivative of pi over 2 is just 0. And now I've got a -5 and a 3. So I would probably clean that up a little and write 15 sine 3x minus pi over 2. Let me let you try this one. What are we going to think about when we do that one? We're going to think of 3 cosine x to the 5th, aren't we? So y'all try that one. Okay, so what did we get for the derivative? We did 5 times 3. 5 times 3 is 15. And then we leave this alone. Go to the 4th. Now we take the derivative of this, which is what? Negative sine. Now we never leave a negative at the very end like that. If you've got a negative, we're going to put it at the beginning. So -15 cosine, we'll put the 4 where it really goes. It's kind of fun, right? I think it's fun. It is. It is. So let's try. What about this one? What happens with the natural log? So what happens with a log? This guy goes to the bottom, and then we take his derivative. So what is that going to be? The 4 is just going to hang out, right? It's just a coefficient. So 4, where's the x squared plus x going to go? The bottom. And then what do we have to do with x squared plus x? We have to take its derivative. So those are pretty easy. It's the radicals you don't like. We'll get used to them. You can if you want to. If you want to say 8x plus 4 over x squared plus x, we could do that. Remember, eventually, we're going to be plugging x's in. So whichever way is easier for you to plug something in. Ooh, we haven't done an e yet. What do you think we do with an e? What's the derivative of e to the x? E to the x. So when you see a derivative, you write down exactly what you see. Always start off by writing what you see. Whatever's typed, you write. Now, this is more than just x, so now we have to take the derivative of the exponent. What's the derivative of x cubed? There we go. You may see it written with this first. Right? Either one is correct. Either one is fine. Does that make sense? Whenever you see e to something, you write it down and then take the derivative of the exponent. Okay, so we'll have our little quiz. All right, so let's check these and see how you did. Did they come out okay? All right, so now we're faced, find the derivative at the indicated point. So that means find the derivative and then plug 0 in for x, right? So what is the derivative? It's going to be 4, 2x plus 1 cubed times the derivative of that, which is 2. So if you put 0 in, what do we get? 4 something cubed times 2. If you put 0 in here, 2 times 0 is 0 plus 1 is 1. So 1 cubed is 1 times 4 is 4 times 2 is 8. And what 8? What is 8? What does that even mean? Yes, this 8 is the slope when x equals 0, right? Because this is some kind of curve, so that slope is going to change at every point, right? Okay, what about this? What do these words mean? That means y minus y1 equals m times x minus x1, right? Well, we know x. If we have x, can we find y? Yes, because y is e to the cosine of x. So what does y equal? Y equals e cosine pi over 2. Well, cosine of pi over 2 is 0. So y equals e to the 0, y equals 1. So we know x and we know y. What else do we need to write an equation? The slope, which is the derivative. So we got to take the derivative. So do that in a different color. What is the derivative? I write exactly what's typed on the paper. And then I multiply by the derivative of that exponent. What is that? Negative sign. True? The derivative of cosine is negative sign, right? Now that we've taken the derivative of e to the cosine x, which is e to the cosine x times negative sign, now I have to plug x over 2 in there. Pi over 2, not x over 2, equals. We already know e to the cosine of pi over 2 times negative sign, pi over 2, right? Now, cosine of pi over 2 is 0, e to the 0 is 1, times negative. Sine of pi over 2 is 1, and 1 times negative 1 is negative 1. And what is that? That's my slope, right? Because it's the derivative. So now that I know the slope, I know x, I know y, I can write an equation. Y minus 1 equals m -1 times x minus pi over 2. And you don't have to write a -1 here. You can just put a negative sign. But there it is. Not bad, right? It's mainly when you see equation of a tangent line that you know you're going to have to take the derivative to get the slope. Now, what does this mean? When you see those words, what are you supposed to do? What does that mean? These words mean take derivative and set it equal to 0, right? That's what a horizontal tangent is, because it's a flat line. It's a flat slope. All right. And you know what? I don't want this to say what it does. Take off the equal on the pi. We always want to be equal to 0 and stop when we get to 2 pi, because 0 and 2 pi are the same place, right? All right. What's the derivative of sine squared x? See if we can do this. We pull the 2 to the front, 2 sine x. We go down to a 1. And now we have to take the derivative of the inside, which is the derivative of sine. And what's the derivative of sine? Cosine. All right, now we said take the derivative, set it equal to 0. So now we need to set this equal to 0. Can you divide through by 2 and get rid of that? Yes. So 0 equals sine x cosine x. Now, how do you solve problems like that? Let's look at algebra for a second. If I gave you this, what would you do? You say, oh, those two things are multiplied. So if one of them is 0, the whole thing is 0. And you'd say x plus 4 equals 0, x minus 2 equals 0. So x equals -4 and x equals 2, right? It's the same thing here. We have two things multiplied. So we're going to set each one equal to 0. So we're going to say sine x equals 0. Cosine x equals 0. And this we have to pull out of our brain because we have this memorized. Where is sine 0? At 0 and pi. And where is cosine 0? Pi over 2, 3 pi over 2, right? All right, one more problem. This is the last one. This is your get out of class card. So I'm going to pause for. All right, let's do it. So we are going to say the derivative is, we bring 4 to the front, go down by a power. Now take the derivative of him, which is 2x, right? So this is the derivative. Now what are we going to plug in? 1. So that's 4 times 1 plus 1 is 2, cubed is 8. 1 times 2 is 2. So now what's 4 times 8 times 2? So that's 32, that's 64. So that's our slope. You probably just wrote a 3 instead of a 6. So now we just plug in x and y. Y minus 16 equals 64, x minus 1. And what this tells us, because we want to get the big picture, is that at 116, that point, the slope is 64. So that's very steep. It's going to look like it's going a curve straight up, right? It's going to go